Great.
Excellent.
Okay. I got it recording. Now I'll share my screen again. Do y'all see my screen? That's so weird. Okay, yeah, the little green out silhouette is not showing up, so that's throwing me off. But if y'all could see it, great. But okay, so back to it. Today's topics. The order that this presentation will go in is we're going to move from cloud native, defining what that means, to going into container technology and understanding what containers are at a high level. From there, we're going to go into Docker utilization, which we're going to understand some basic Docker features, and then finally we're going to move into containers and data science and how to utilize Docker for those projects. So no doubt we have heard quite a bit of hype about this technology. You probably have heard the name Docker thrown around a bit, but and you may have played around with Docker before, but most technology professionals have yet to try it out themselves or learn much about it. So today, let's discuss the benefits of Docker that Docker brings us as IT and data analytics professionals. Okay, so we're starting off with a journey towards cloud native. So in the beginning, we had physical servers and mainframes and all sorts of other junk. So we had our own server rooms. We still refer to them as data centers. We had physical machines that we had to have our own employees, our own ops teams that were significantly bigger than they are now, monitoring and taking care of these machines like they're our baby, or else they're going to overheat and die, or their components are just going to fail after X amount of days running, or months, or years. Of course, physical servers are still around today. If anyone's not aware, a slang term is bare metal. I'm running bare metal. That means physical servers, just in case you didn't know. And that was all prior 2002, really. Then our next stop is virtualization. Finally, from 2003 to 2010, we got finally you could with the tool of a hypervisor, abstracting away the infrastructure below it, we finally can split our physical resources into virtual resources, so we could have many virtual machines on one actual physical machine. You can request these resources from your server team, your ops guys, or whatever formal process companies have in place. It better utilizes the resources, the physical resources that are available to you. And but still, this was monitored by your own employees that you had to pay, and you had maybe required less than not using virtualization. But you still have to have a lot of employees, and of course, they're still around today. People manage their own physical servers with virtual machines running on them. So that brings us to about 2010 to 2016. This is all generally speaking, timeline-wise. This is when the cloud, and my opinion, and some of my colleagues, their opinion, when cloud really took off. So what did the cloud do to us? It's like on demand, but for compute power. Essentially, the cloud is a computer you don't have to take care of. It's someone else's computer that you literally rent compute power from for a reasonable rate. More and more, we're seeing organizations adopt a multi-cloud strategy. By utilizing multiple cloud providers, you bring a lot of benefits to your organization. So choice in providers reduces risk, assists in disaster recovery, and expands the reach of your service to more regions than ever before. Well, with this, end users experience lower latency and increased reliability. Being cloud agnostic, it allows freedom of choice, essentially. No vendor lock-in, or, reduced vendor lock-in, significantly increased cost savings, and improved operational efficiency. However, this path to multi-cloud infrastructure, it can be challenging. Building solid infrastructure presents a number of different challenges, but when done correctly, it enhances and accelerates any organization's development efforts. Production can be frictionless. It helps pave the way and makes production as frictionless as possible and not locked into a single vendor again. It also gives you several benefits like downtime. There's greater redundancy in the cloud than there is on-premise, most always. So if a cloud provider suffers an outage, another region can pick up that slack. And on-premise apps might have failover ready, but there's a good chance that if the server goes down, the app goes down with it. And downtime's the bane of our existence, the operations or infrastructure side of things. And really, automation. That's a huge one. So much of the cloud is automated, and that includes app management. The benefits of cloud-native delivery, especially speed and agility, significantly rely on a substrate of reliable, proven, and audited best-known processes that are executed repeatedly as needed by automation and orchestration tools, rather than through manual intervention. So engineers should look to automate virtually anything they do. And that's what this cloud's really provided us. I would like to point out the infrastructure as code. Really, that's a huge defining feature that the cloud and cloud native kind of brought about. For those that don't know, infrastructure as code is the process of managing and provisioning computer data centers through machine readable definition files, rather than physical hardware configuration or interactive configuration tools. So defining the resources that you once ran and created, not in the AWS GUI. No, you could just generate a YAML or an AMI, or creating a YAML file to specify the resources that you want to be run. It's really great. And another definition really would be like the management of infrastructure, whether it be networks, virtual machines, load balancers, anything you want, in a descriptive model using the same versioning as a DevOps team uses for their source code if they're trying to create scripts to automate this. So that was a little bit of a rabbit hole we went down, but we have a lift and shift from the on-premise to the cloud. In business buzzwordy terms, it just the cloud increased agility and time to market, zero downtime, all that kind of stuff. It's that was huge, and that was huge for all of us as consumers and tech professionals. And now, 2016 was the general consensus. Now we have cloud native. So before I say anything else, I feel like it's truly just cloud native is reaping all the benefits that cloud native offers us, like just taking advantage of every benefit that we can and building technology on top of that. So first and foremost, when we speak about cloud native, I should really point out that at the heart of cloud native is open source technology. This tech that we're all building, they really have a community focused aspect to it, and the projects hosted on the cloud native cloud foundation can be contributed to by anyone, which, by the way, CNCF, they're, I don't know, the managing body, sort of. I think they're a non-for-profit, but I'm not sure about that. But, cloud native, it's really a term to describe container-based environments. Cloud native technologies are used to develop applications built with services packaged in containers, deployed using a microservice architecture, and managed on elastic infrastructure through agile DevOps processes and continuous delivery workflows. So traditionally, operations teams would manage the infrastructure resources allocations to applications manually. Cloud native applications are deployed on infrastructure that abstracts the underlying compute, storage, and networking primitives. So developers and operators dealing with this new breed of applications don't directly interact with APIs exposed by the infrastructure providers. Instead, the orchestrator handles resource allocation automatically according to policies set out by DevOps teams. So the controller and scheduler, which are essential components of the orchestration engine, the orchestration engine, handle resource allocation and the lifecycle of applications. So cloud native platforms like Kubernetes, which I'll get to in a minute, but that's, almost synonymous at this point with cloud native, is expose a flat network that is overlaid on existing networking topologies and primitives for cloud providers. Similarly, the native storage layer is often abstracted to expose logical volumes that are integrated with containers. You can allocate storage to this, storage quotas, and define networking policies that are accessed by developers and resource admins. So your Kubernetes admins, you're going to have those. The infrastructure abstraction not only addresses the need for portability across these cloud environments, but also lets developers take advantage of emerging patterns to build and deploy applications. Orchestration managers, that's it's where we're all moving to, and orchestration, container orchestration, is really at the heart of cloud native. Kubernetes is an ideal platform for this. That's the industry best practice, and I'm learning that the industry best practice is really what you want to go with, usually. And it's become the de facto operating system for the cloud. In much the same way, Linux is the operating system for these underlying machines. Most VMs you're running in production, it's usually all R-Hell, all enterprise Linux. As long as developers follow best practices of designing and developing software as a set of microservices that comprise cloud native applications, DevOps teams will be able to package and deploy them into Kubernetes by using containers. Because again, Kubernetes, these orchestrators, they manage the containers. That's really what developers should keep in mind when designing cloud native applications. So that was a whole spiel, but cloud native, it's all about creating more stateless services. So not requiring state in the application, utilizing loosely coupled microservices, leveraging Docker or any kind of container technology tool, and even taking full advantage of serverless, which I did not have a spot for that later on, so I might as well hit on serverless now. There's really not much of a serverless market. It's more of an AWS Lambda market because most of the people leveraging serverless, they're pretty much all utilizing Lambda as opposed to, I don't know, I've seen some using Azure Kubernetes, or no, what is this? I kind of forget what the serverless feature for Azure is, but I've seen a few people using Azure and Google Cloud for their serverless, but really Lambda is dominating. And that's where you just have to push your code by just your Python files or what have you up to a serverless repository, and AWS takes care of the rest. You only get charged by how many times that code gets pinged. So that's pretty cool. And automation, of course, and just having all your resources able to talk to each other. That is my best explanation of where we are with cloud native and what it's all about, really. So here on this side, before I go on, do we have any questions? I'm going to take a quick drink of water. Okay, so driving on. Here we can see that containers are really kind of the happy medium in the continuum of the cloud native technologies that are available. Of course, we still have virtual machines, and actually containers on top of virtual machines is a very harmonious relationship. And that's really how you're going to be deploying any containers in production, containers on top of a Linux machine. And then over to the right, I think it's going in ease of use. Because serverless, I mean, you really don't get much easier than serverless. And virtual machine, they can be somewhat complicated sometimes, depending on the networking or what you're doing. But yeah, really, you could see here that, this is the territory of the infrastructure as a service, on a slider, essentially. That's the best way to describe it. Now, say you want to build a website or an application, you want the license of whatever it may be, and to make sure that the system on which you're working fulfills your computational capabilities. Assuming all that, then that's when infrastructure as a service comes into the picture. But yeah, that's our continuum of the cloud native technologies. And here's a little bit of information on the landscape. So I hit on this earlier, but here we see this is the logo for Kubernetes. They're huge. Like I said, a lot of people think it's synonymous, Kubernetes, with cloud native. OpenShift, that's the oh my God, the Red Hat, the flavor of Kubernetes. It's different in ways. You instead of using kubectl, that command before every other subsequent command, you're using OC. OpenShift is pretty big for Red Hat stacks. The Linux Foundation was the traditional, like, open source, awesome organization, and cloud native, the CNCF, they're really dominating and leading the charge so far. And of course, with the adoption of containers and just, they're taking over so far with the future of managing applications. They created the OCI, the Open Container Initiative. And that is really just to ensure that your development experience with your user experience with containers is kind of more or less the same across the board. Docker was a huge player in this. I mean, they were already the market leader basically at the time when they were, kind enough to form the committee. But OCI, they really level the playing field for everyone and make so vendors don't go creating radically different products that just confuse the heck out of you when you're trying to spin up a container with an app inside it. Real quick, just to not prove a point, but like prove that, containers are coming, or cloud native is becoming more and more mainstream, becoming more and more of a thing. This is a really good survey done by the CNCF. And here you'll be able to see more the adoption and the benefits the cloud native really brings to us. So you can see here that the rate of which companies are being able to deploy code, or push code daily and weekly has increased significantly from 2018 and 2019. Back in 2018, a lot of companies were doing daily pushes already, or weekly. Really cloud native is producing so much more reliability and just agility with being able to get code, be able to push code to production. So that's pretty cool. And a lot of these releases, they're CI/CD tools. It's a lot of it's automated. It's really interesting. I've seen it's actually, there's quite a few best practices of using a hybrid approach to, in your CI/CD pipelines, just as a final security check. There's the little security checkpoints. That's kind of a best practice, but fully automated build processes and manual and mostly hybrid and manual. They're becoming more and more, as you can see here, the difference between 2018 and 2019, the de facto standard for pushing out code. People can check in code. Tons of people are doing it multiple times a day or a week. Very few are doing it monthly. Where's your cloud? So public cloud versus private cloud or on-prem, it's just so much easier utilizing AWS or GCP or Azure. I mean, good Lord, makes life a heck of a lot easier. So you see that a lot of usage there, but of course people still got their on-prem data centers. So, that number is high as well. And then here we could see the use of containers, like the actual adoption, which is really nice. You'll see development's gone down, they've all gone up essentially, especially in production. People are trusting containers a lot more. So it's time to join the party. You can also see that there's quite a few that have like well over 5,000 containers running in production, which is crazy. So there's that. That's interesting. And the usage, the most popular by far is the AWS EKS. Well, I wouldn't say by far. Google and AWS, they're pretty solid when it comes to managing containers. Docker Desktop, of course, when we get into the container portion, when you run Docker Desktop, when you're interacting with Docker on your local machine, it's all through Docker Desktop. And then AKS, Cube, and all this. OpenShift is a lot smaller than I imagined, but yeah, you've got the rest of them. I would only pay attention to here to the left. Service meshes, let's not even touch that because, good Lord, they're a pain. Utilizing the cloud native storage of choice seems to be Amazon Elastic Block Storage, which is surprising, but I've never used them, but apparently they're pretty good. And more and more, like a ton of people are adopting serverless right now. So I'm not touching on that during my presentation, but I strongly encourage you to check out serverless, leveraging that in your workflows as well. And like I said earlier, Lambda is just dominating when it comes to serverless. So those are the serverless, that doesn't matter. And I think that's mostly all I want to show you. Kubernetes is like the CNCF baby. That was like their most mainstream product or graduated project that everyone seems to use. Helm is quickly becoming the standard of managing your packages for Kubernetes. I believe, yeah, that's really all I want to hit on here in this. So we'll continue back to our presentation. And just to kind of drive the nail home, these are the companies that have fully adopted a container-based cloud-native environments. And this is how they put their apps out into the world. We have calls with PayPal all the time. Citi, good God, we're always talking with them. USAA, literally every branch of the DoD, every industry you can think of, all these names, can name drop for days. People are getting on the cloud native container bandwagon with intensity. That's the future. So really, that was cloud native. Let's take a stop here for any questions and review kind of like what we've learned. I said to dumb it down, just a quick explanation. Cloud native means container-based environments. Quick and easy. To summarize, you could think of cloud native as a term used to refer to a microservice-based environment, usually running in containers, which are managed by a container orchestration tool, all of which running in the cloud or multi-cloud environments or hybrid cloud environments, which is on-prem and in the cloud. that is also taking full advantage of the modern infrastructure and benefits that the cloud provides. These, of course, being cost savings, ease of use, security, next to zero downtime, and just built-in best practices in a way to ditch the data center, so to speak. And so with that, I can take any questions if anyone has them. Okay, so with that, we'll drive on and get into some containers. All right. So first, we'll begin with a high-level overview on what container technology is. It's difficult since you really can't point at it and say, there it is, that's a container. This is because containers, the idea of a container is an abstract concept. I'll get into that in just a second, what that means. So what is a container? So my definition is, first, a container is an abstract concept consisting of 3 Linux processes that aren't new, by the way. These processes are C groups, namespaces, and change of root directory, or commonly referred to as chroot, change root. A container is simply a running instance of a container image. Kind of think similar to like a virtual machine image. So it's really, or like an ISO file. So it's really the image we deal with most, not the container. Essentially, a container is an isolated environment for an app. The container contains the app itself, plus the required dependencies and libraries for the app to run. This effectively bundles everything the app needs to run in one self-contained package. This package can be run on top of a container runtime across a variety of virtual machines with different operating systems. You know, this is because the host OS and hardware are abstracted away from the equation. The container runtime will be the same across machines. A practical example of this is you create an application on your Mac, your local machine, and then containerize it using Docker, meaning you create a Docker file specifying to copy that application's code when built. This produces a container image. You can then push that container image to Docker Hub or any container registry that you like. Then your colleague can pull that same image onto his virtual machine running in a Ubuntu operating system, any kind of Linux, plus a container runtime on top of that operating system. The result is this containerized application will run the same way on your colleague's virtual machine as it does on your MacBook. So yeah, you can see how this technology benefits us greatly when it comes to collaboration amongst team members or remote teams, especially now in our remote culture. It is my belief that containers are the building blocks for modern infrastructure and a core component to a modern approach for managing applications. Containerization technology has proven to be an essential building block in the creation of modern infrastructure. By bundling an application with all of its dependencies, containers produce an immutable artifact that is abstracted from its underlying environment. When you decouple the application from its environment, it allows workloads to run in a consistent manner on a developer's laptop, up in the cloud, or on-prem. Furthermore, a containerization will be used in conjunction with virtual machines, which I touched on earlier. They will be a core part of how we manage applications in the future. It's how we manage applications now, from what I see on the security side. We refer to a container running in production as a service. Just kind of want to put that out there. So a container is just a running instantiation of a container image, which is like just a flat file. And then it's like, you do your little Docker run magic or Docker build, and it's like, you create your container. Do I have any questions about that?
Ryan, so is it fair to say a container is sort of like a micro virtual machine without any dependency on the operating system?
There are certainly minute differences there, but yes, you can absolutely agree with that. It's actually a container is actually processes. It's built out of processes. It's separating. Yes, I would agree with that explanation, just for simplicity's sake,
Okay.
or
I'll
that
save those
definition.
questions towards the end.
Okay. Sure. So, why use it? The benefits, are all outlined here. When we say speed, we mean it. Containers are extremely fast compared to all your alternatives. They're very resource efficient, and they're simple once you get the hang of it. Once you get over that knowledge gap, and improve productivity. There's a lot of benefits to this. The biggest of which, you can't really break stuff. Just if you mess up a container, destroy it, spin up a new one, no harm done. That's like kind of the best part. So here's a great way to differentiate the two between virtual machines and containers. So here we see the difference between virtual machines and containers. So with a containerized environment, we've got the physical infrastructure, and then we've got the actual host operating system, which can be anything: Windows, Ubuntu, Mac. And then on top of that operating system, what's abstracting everything away is the Docker engine, or just the container runtime, because there's more than just Docker out there. The container runtime is abstracting all that away, and it's interacting with the kernel. So your applications, they don't have to. So on top of that runtime, you could have any number of applications. It could be 1, it could be 1,000. It's just depending on the resources that are available on that host. As opposed to the virtual machine, which is generating a lot of bloats. So, we've got our hypervisor abstracting the physical infrastructure away, but you've got 3 different guest operating systems for each virtual machine running on this physical infrastructure. So that's just very inefficient to have just one app per one virtual machine, as opposed to having 1,000 apps per virtual machine. So a lot of business value there. Moving on, I want to point out, here's another, the container engine. Here's just another image that looked good. It showed the bins and little libraries. So each app has its own self-contained libraries, frameworks. Its dependencies are bundled in with that application, which is really great. And here I wanted to point out that that the containers can also share libraries and dependencies. If they're the same container and it's the same thing, your container runtime, or Docker specifically, it's not going to generate the bloat. It's going to share the same bins and libraries across the same app X amount of times, as many times as there is. So we don't have a huge duplication effect here, which is really cool. 1 second. All right. So here is where I want to point out there's different container options out there. Of course, we got Docker, but there's a whole container ecosystem out there. Say you are using primarily Red Hat products at your company. Red Hat provides their own orchestrator tool known as OpenShift. That is pretty similar to Kubernetes, and they utilize Cryo as opposed to Docker, as well as Podman. Oh wait, correction. They utilize Podman mostly nowadays, which is just another container runtime. Just think of it as Docker, but different. And Cryo, I forget where I've seen them in the wild, but I've seen them around quite a few times. And sometimes when you're spinning up a virtual machine, you aren't even sure what container runtime you're using. You kind of always assume Docker, but if you're running an OpenShift 4 environment, you're probably getting Podman, whereas opposed to OpenShift 3, you're getting Docker. It's kind of weird like that. And lastly, pointing out Container D, Docker donated this project to the CNCF back in 2017. So Container D is a container runtime that leverages something called runC, which is like the underlying technology in Docker. So Docker, once they were like a mile ahead of everyone else, they said they were like, okay, we'll have an industry standard. That's kind of our standard, coincidentally. It has an emphasis on simplicity, robustness, and portability. Container D is the core container runtime of the Docker engine. I'll repeat that. Trying to get my little bar to go away. Sorry about that. So yeah, you've got quite a few different options. Let's go back here. So with that said, introducing Docker. I'm going to be doing everything in Docker for this presentation, and it's really popular because they took that container technology, which, by the way, that container technology has been around for a long time, and they've made it easy to use. The reason why no one used it in the past is because it's like insanely complex to use, and it's like it wasn't worth it, honestly. But now we got now we got Docker. And to define it real quick, it's a platform as a service product that uses operating system level virtualization, delivers software and packages called containers. So a container, you would define those as packages. They're isolated from one another, and they bundle their own software libraries and config files. They communicate with each other with channels. They have a whole Docker container networking kind of deal. They run by a single operating system kernel and therefore use fewer resources than virtual machines. So, Docker really think isolated environments. It gives you advantages similar to running an app inside a VM, but better. Your app always runs in exactly the same environments. It runs and behaves the same across devices. It lets you sandbox projects and keep them separated, which is very good for security. It makes it easy to work on someone else's project, and it allows you to pull their project without having to download all the dependencies and tools for that the project needs. And Docker gives these advantages without having the hassle of spinning up a lot of these virtual machines. So it's a lot easier to spin up containers. Now generally, using Docker is going to take more work for a data scientist versus a local deployment. So, but however, there are several benefits to Docker. Reproducible research. If you can deliver your analysis as a container, then other data scientists can rerun your work. Explicit dependencies. In order to set up your script as a container, you need to understand the dependencies of your code and any additional libraries that may be needed and their versions. So that's good, understanding exactly what your app needs. Improved engineering collaboration. If you want to scale up a model you've built, providing a Docker file to your engineering team is going to go much further than handing off an R or a Python script. It also calls out the dependencies that the code needs in order to execute. And then the broader skill set. That's our last one. Being able to stand up infrastructure as code is a very valuable skill set. And using Docker containers can help data scientists to start developing that skill set. And just in case, y'all might have seen it on the slide, but we have a tool called Portainer.io. You mainly interact with Docker through the CLI or via Docker file. But really, if you want Portainer.io, Portainer is a tool that gives you a GUI for your Docker environment. So that's kind of cool. If you're really into GUIs, then by all means. Otherwise, we're rocking command line or terminal. Okay, so real quick, let's go into the components here. So we have the platform, which is the software that makes Docker containers possible. We've got the engine, which is a client-server application. Usually, people just use the community or version. There's not a whole lot of reason to use enterprise. If you don't use enterprise unless community is not meeting your needs. The client, you interact with the client through the Docker CLI. So that the client interacts with the daemon. And the daemon is what the Docker server manages your key things. Volumes. One neat thing about containers is that, once you just spin down the container, once you're done using it, that data goes away. So that introduced the problem, like how do we make our data persistent? So that's where volumes comes in, and I'll get to that in a little bit. We've got registries, which that's remote storage for images. That's where you push your images into the cloud. That's where you store them, because if you're rocking containers, you end up with a lot of container images. And then we've got Docker Hub. That's like the default largest Docker registry. It's great. And yeah, a repository. People mistake the repository name for like the image name, and that's not the case. We'll get to that in just a minute. But of course, I'm talking way too much, and we're burning through a lot of time. So I'm going to try to speed it up a little bit. Here's a visualization of those concepts that I just spoke about. We've got someone creating a Docker file, defining, which is literally you writing instructions in Docker's specific way on what you want to spin up or what you want run. So you can Docker build, you can Docker run. Those commands you see there, that is the commands that the Docker daemon will execute. So we've got the host, you've got your images running on your machine, you've got your running containers on your machine with the daemon, and then the volumes, I'll get into that in a minute, but you could push it up to a registry. Or you could pull it from a registry, and you know, the Python 3.7 Slim, I think that's the most popular image on Docker Hub. So point is, you pull any image you want basically from Docker Hub, which is great. Also installing Docker on your local machine, whether it be Windows or Mac or Linux, pull it from Docker Hub, create yourself an account. Strongly encourage you to do that. This kind of reiterates, it kind of hits that point home. Docker build communicates with the daemon, creates an image. You can pull, it goes to the daemon, goes to the registry, and then you've got your image right there. And then Docker run spins up a container. Those are our three core commands, really. Excuse me. So here we have the Docker file, just a brief explanation. This is what it really looks like. We've got our Docker file, copy from node. So this is the base image it's coming from this image pulled from Docker Hub. And it's always good. You can use latest. It's not recommended for security reasons, and just for, it's not a best practice at all. Because, you know, if the latest version of that image changes, then it's not going to be right in your container. So specifying a version is always good. Your working directory inside that container, because you can get shell inside these containers when they're running. And they specified an environment variable, which is port 80. So they want port 80 to be environment wide. And then they're copying the local files here. Let's split this in half. Package.json on the local machine, and this is what it's going to be inside the container, code/package.json. Oh, shoot. And then we wanted to run npm install. We wanted to copy the code, copy the current files in this directory to the code directory. And these are the commands to kind of kick it off, so to speak. Here on this slide, we have a lot of our common commands that you can run. Big list of common Docker file instructions. Got the from label. Let's see if there's run. That's creates. There's oh, I'll get into it. I think I have layers in here. I talk about layers, but a container image is made up of many layers, and you get a layer when you copy the file, when you use the copy keyword inside your Docker file. So whatever you defined in that Docker file, the Docker goes from top to bottom. And so it's going to hit that first copy and create a layer, and then it's going to hit the second copy, create another layer. So it's kind of interesting how you can, and you can specify layers whenever you're building a new image. This is like Legos. You can plug and play all day long. It's kind of interesting that way. It's not worth going through more of that. So container images and Docker images. A Docker file becomes a Docker image when you run the build command. It's made up of layers, like I mentioned. you view the contents of each layer on the host, or a different method on Mac, because it's actually, Docker is actually running as a virtual machine on your computer. Fun fact. And or you could use the history keyword. Again, here's another example of the layering method, and just how a Docker file really looks like. And just to really drive that point home, we have a little metaphor. I like, let's make a pizza. And so we could think of the Docker file as a recipe on all the ingredients and the time, the steps you need to create this pizza. We can think of the different ingredients as the layers that make up this image. And then we could take that recipe and those ingredients and combine them to build us our final Docker image. That's what you move around. That's what you pull. That's what you push. That's what you can share with colleagues. And that's what you run to create a container, which is the running instantiation of that image. I feel like I might have repeated myself a little bit, but do I have any questions? I just hope I'm not going too slow for anyone or just repeating myself too bad, because I have the tendency to do that. Any questions, real quick? Okay, so here, here we have, we're going into container registries. I've given myself way too much of a script to work with. I'm getting rid of all of that. Just think of container registries as storage for your container images. Up here, like, I'm into best practices. That's the best way to do things. The AWS container registry, huge leader. A lot of people leverage that. We've got the Red Hat, I think it's Quay is what they call it. You can use Red Hat if you're into that kind of environment. Or you could use Microsoft's thing. And then down here you have Docker Hub, which is still good to use, but less enterprises use Docker Hub. It's fine for your little small analytics team or just for your personal use, but once you become a big enterprise that's adopting containers like a lot, then you got to go with a cloud-provided container registry, really. That's fine. Oh, Docker Hub, this is great. It's a major part of the Docker ecosystem, really. All images, unless otherwise specified, come from Docker Hub. Whenever you Docker pull, it's coming from Docker Hub. The repositories allow you to share container images with your team, customers, or the Docker community at large. Let's go into what a repository is real quick, because people get them confused with the names. A repository is a collection of Docker images with the same name and different tags. So you could specify different builds with tags. And the tag is really an identifier for the image. Usually a repository has different versions of the same image. Python, for example, you've got your Python, then you've got your Python 3.7 Slim, which is a lot less bloat. The 3.7 Slim is the tag in the Python repository. So, you know, if you just want a smaller footprint, a smaller file size, and you can push a repository or a single image to this registry, of course. So Docker images are pushed to Docker Hub through the Docker push command. A single Docker Hub repository can hold many Docker images stored as tags, as the different versions. I'll go ahead and just quickly show you what tab I am on. Good Lord. There we go. See, and here we have our little Docker Hub. So this is my name, Dev Guy Ryan. This is my demo repo. I've got, you know, I pushed this a little bit ago. You only get one private repository, which is the basic freemium version, and you get unlimited, I think unlimited public repositories, because sharing is caring. And you go here to explore, go to Docker CE. You can, let's go, download Docker for any kind of operating system that you like. Ubuntu, you got for all your VMs, and then for Windows and Mac. So that's where you go. Then you go to containers, And then you can sort by official images and stuff. And you see MySQL is really popular. Python, of course, is super popular. Java, pretty much, since this is data science, it's Conda environments. You could get mini Conda and you could get real Conda, like the giant version, and pull it all down from Docker Hub, which is really great. So I think, if you're trying to leverage it with your analytics team, you can just simply create an organization. You've got the option of a free team or just the actual where you pay. And I think in production, people, if you're leveraging Docker Hub, you're using this Teams version. Granted, Docker Hub, I've heard mixed reviews on security. Like I've heard, I feel like this has been addressed, but AWS and some of these cloud providers, they've got phenomenal built-in security standards that they hold themselves accountable to. So that's why so many people leverage AWS, for example, as opposed to Docker Hub. So moving on from there, Docker volumes. Like I said earlier, when the container dies, the data goes away, which, you don't really want that as an analytics professional. So in that case, we have two different methods. There's actually more different methods of mounting storage onto a container. The two most popular are volumes and bind mounts. Bind mounts actually route to a location in your file system. So something that you can navigate to, just CDing or change directory on your Windows or Mac. And then volumes, which is great. That's the Docker. That's Docker's area. I believe you could still get there, but Docker manages the volumes, and I do not believe they can escape the Docker volume, the Docker managed area, into your local file system, which is good for security. And then, of course, you're seeing up there TMPFS mounts, TMPFS mounts. That is for memory for the life cycle of that container. So once that container dies, the TMPFS goes away, or that's the storage. Like, it's for a session, yeah, or like for maintaining state, I believe. But a lot less common. Volumes are the way. That is how you keep data persistent in Docker. So Docker Compose, this is a big one. Docker Compose makes managing multi-container Docker applications very easy. With Compose, you use a YAML file to configure your application services. So then with a simple Docker Compose up command, you create and start all the services that you defined in your Compose file. It is a huge time saver for multi-container applications, which your dev teams, they're obviously creating plenty of multi-container applications. On the analytics side, the same thing as well, because you've got your database and then you've got your actual work environment. So you get into Docker and you'll quickly find yourself wanting to leverage Compose. And I wholeheartedly encourage you to learn that. The next one. So here we got container orchestration. I'm not going deep into this. No, we're not going deep into orchestration, but this is where, we already did essentially. This is where we've got Kubernetes, and then the native Docker tool for orchestration is Docker Swarm. Docker Swarm is really good. It's a lot easier to use than Kubernetes. People like it, just it's not, it lost the container wars. I mean, the Kubernetes won that hands down. So everyone thinks it's more efficient to roll with Kubernetes. But if you're a very small team and you want to spin up quick and get up and running with containers and orchestration, I wholly recommend giving Docker Swarm a try. You'll catch on. It'll make a lot more sense a lot more quickly than Kubernetes will. So, okay. Here we have a little bitty demo. Give me 1 second just to get things set up. Okay. So I'm gonna bumble my way through this, if that's all right with you. It's gonna. I've actually never done like a technical demo, I guess. So here we're gonna do a pretty basic thing. We are going to. I want to real quick, for the sake of doing this, I'm going to remove this file. All right, cool. We are going to git clone. We're going to clone this repository real quick. Oh, did I feel that? Oh, okay. Well, let's just pretend we just removed it and we'll just roll with it. So we would run this command. I don't think it's going to work because we already did it. Unable, it already exists. But so we would pull this repository from GitHub or whatever, wherever, and then we would run docker build, and then we would tag this image, bulletin board 1.0, and then we would put a period to put those files in the current working directory. It didn't work because I didn't actually delete the thing. I had to test it earlier, but you know, it's gonna, that's whatever. So we tagged it, and now we can run it. So to see all the, just to see all your running containers, you could do docker container ls. You can see here that I have no running containers at the moment. We can do a -a to see all the containers that have been run but are no longer running. We could do the same thing with image. We could do docker image. These are all the images that I've pulled down to my machine. You could see this Kate AS. These are our Kubernetes, and then you see here for Docker. These are for Docker to take care of the built-in Kubernetes on your machine, and just for some other maintenance stuff. But you can see here Ubuntu, Jupyter Data Science Notebook. That's something you pull down from Docker Hub, and that's all great. So what I would do is I'm going to run, I'm going to do docker run, I'm going to cd into that bulletin board directory. There we go, we're in here. So, oh well, it doesn't matter with the docker run, sorry everyone. So we're gonna docker run, and then we're gonna specify -p, which is, or -d, which is, we want this container to run detached. So we don't want it to spin down and die the second that it's run, which you can do for certain Docker containers running like a simple script or something. So you would define it to be detached, and then you could specify -p for the port you want it to listen on. So here I'm just gonna do like, oh, it disappeared. 1 second. So we're gonna go with that port, and then we're gonna, it's already named. I'm gonna use the name bulletin board. Oh, shoot. All right. So then we're going to go Docker container ls, and then here we can see it running. So after that, we're going to go to localhost 800, and here we can see that running container running on our local machine. Of course, I mean, you could add a QDN to it, a fully qualified domain name, to where, and you can have it not running on your local machine. You could have it running up in the cloud on a Linux virtual machine, and then this is a real app. Yeah, so you do all that. So does that help at all? to kind of just see it in action a little bit?
Sure does.
Great. So yeah, we've got, that's really one short little demo I had for y'all. And next, let's dive into the actual, why we're all here. Sorry, I'm just into like the data science side of things. So why would you want to actually leverage containers other than what like I've already kind of specified? So let's take that with first, how do analytics professionals actually use the containers? It's too easy. In a nutshell, containers provide you environments to work in. That's how you use them. This environment is easy to use, it's isolated, it's immutable, as well as easy to reproduce and share. And maybe most importantly, it's super fast to spin up, which is perfect for collaboration for your analytics team members. They're lightweight versions of your traditional virtual machine-based environments, but they have a very small footprint on your server, and they are easy to spin up and down or destroy, and giving you, the analytics professional, a lot, just it frees up a lot of time, and it makes you able to do your job a lot more easy. So they're very fast to boot up in comparison to those machines, like I was saying. Even Windows containers, which, I didn't really get into Windows during this, but prior 2016 or 2017, you did not want to use Docker for Windows. That was not working out so well for people. Docker for Windows was a pain. I'm happy to tell you though, because I know we're probably more predominantly Windows audience here, we got plenty, or a full functionality essentially. A Windows container isn't technically a real container like a Linux container, but you're going to be able to run everything great, and with minor differences. But yeah, so you Windows users, you're good to go. They make creating repeatable data science environments very easy due to the containers, just how their nature, how they run really. So, but for a data scientist, running a container that is already equipped with the libraries and tools needed for a particular analysis eliminates the need to spend hours debugging packages across different environments or configuring custom environments. For example, you can easily launch isolated Jupyter and RStudio sessions outfitted with your choice of libraries and tools. We're not going to describe containers anymore. What's really important is just the standardization and the efficiency that containers provide. Rather than you having to build a new environment for every analysis, your IT team can put the tools and packages required for certain types of analysis into a container. Whether that be scikit-learn, TensorFlow, or Jupyter, for example. Then you can create an image of that container and have every user boot up an isolated, standardized environment from that image. So you're all working with the same exact thing, which from what I understand, I'm kind of out of the analytics game since graduation, but I understand having that same exact environment is very important for y'all. And things can go wrong when you're running these models, and I'm sure y'all don't want that. So I know the process of getting an environment up and running varies from company to company, but we want our data scientists to have the fast user experience while still working in a governed, centralized architecture, and not have to use their local machines to do it. But in most cases, it takes far too long to submit a request to IT or wait days, or fill out one of those forms they have, like a change request form. That's the wrong word. Change management form, or just those web pages they have for you to request virtual machines or request compute resources. So, you know, compared to this method of simply extracting the environment away from the machine, you know, that's just a lot better way to do it. And so what are the benefits of using containers in this way? Quick and easy, got 3. Easily creating identical and repeatable data science environments. Speed, containers spin up extremely fast compared to anything else. And isolation from your machine, your other files, and your applications, keeping everything separate. Huge deal, your security team will love that. So really the only disadvantage that we have here with containers is really just the initial knowledge gap. It's a new method of doing things. We are, as tech professionals, we've reinvented the wheel yet again. However, you know, that drives people nuts that have been tech professionals for a long time, but we're making it a lot better now. You know, like we're really paving the way for at least the next 10 to 15 years of like, this is pretty much the way we're gonna be rolling with containers. That's what we're agreeing on. You know, these are the new virtual machines, essentially. So you're future-proofing yourself, and you know, getting over this knowledge gap, you're opening like a whole different world compared to how we used to manage apps, which is really cool. But to sum it up, containers solve a lot of problems associated with doing analytics work, especially at scale or at the enterprise level. They take the pressure off of IT to produce custom environments for every analysis, standardize how data scientists work, and ensure that old code doesn't stop running because of environmental changes. Now, let's see firsthand an example of this in action. This might go slightly smoother, but can I take any questions while I'm getting this all put together? Also, I think I busted time by a little bit. We're going to wrap this up real fast, I promise.
Good stuff, man.
What's that?
I said good stuff. So I'll throw in a question.
Sure.
If each container is contextual to a particular type of software or technology, so let's say a simple web application, right? So you write a HTML or basic some sort of a scripting language, markup language.
Sure.
Say .NET, right? A .NET application and a database. So do you
absolutely.
need 2 containers now? A .NET container and a database container?
Yes, sir.
Right.
Yep. You want to have that .NET application running in one container, and then using Docker networking is actually pretty robust. It's great. Containers can talk to each other very well, and that .NET application will call that database, and you would define the Docker volume pointing to that database. So it will, they'll communicate with each other, and the .NET application will pull that data from there.
So when you install Docker on that particular computer, should you configure all the containers that you need ahead of time to run those corresponding containers?
Sorry, I did miss that. What was that?
I'm trying to see, like, so let us say on my computer I have installed Docker, right? So based on what containers so what applications I need to run, I have to pick all the containers and then install, or does Docker come as a cumulative package of everything?
I'm so sorry. I was like focused on something else. Please, Docker comes with everything except for the images that you want to pull from Docker Hub or somewhere else.
I got you. So, okay. Makes sense.
Yeah, I mean, the Docker desktop application, that contains your client and the actual Docker daemon, it's all inclusive, essentially. Shouldn't have to be downloading any other plugins.
Okay. Thanks, man.
Yeah, no problem.
Anyone else has any other questions?
Oh, okay. I'm sorry. I forgot where I left off with this. Essentially, all you had to do is, so what I did is, I just pulled another repository down from GitHub. And here I was, and this is excuse me, I could actually, you could pull it down now from Docker Hub using this repository path. So that is my Docker Hub account, and this is the actual repository that it's specifying. And this is the Jupyter Notebook. We're just setting up a really basic data science environment, but I'll come out with subsequent stuff that's more advanced, and having persistent storage and all that. So super easy. You just Docker run, specifying the ports, and here I would just take this address, just copy this real quick, and go up in here and enter it in there. So now I am running Jupyter Notebook. I swear I do not have Jupyter installed on my machine anywhere. I think I had Anaconda on it one time, pain to delete, but got rid of Anaconda. So this is simply an instance of Jupyter Notebook running inside a container, which it was super easy. I just literally pulled it down from GitHub. It's someone else's project, and it just accesses it in a container. You can, here we can go into this notebook that's already created. So here's like a demo notebook. It works perfectly fine. You got your output, see it's running. We got pretty graphs and charts, yay. It's actually super basic. Please do not judge anything analytics that I do, because it's not good. You can leave it, and you can create your own notebook. Python 3, RStudio or an R is not on this one, but if this were a mini Conda environment, if this was a mini Conda container, I believe we'd have all that stuff. And it'd be great. This is really just the file that it's accessing that was copied from my machine into this container when I actually built it and ran it, which is pretty cool. But yeah, you can build to your heart's content here, and you could name it and save it. However, we don't have a volume specified here, so it's not going to save to my machine. I could do a demo or a tutorial on how to do that at a later time. But so like this untitled notebook, if I did a bunch of work in there and then I just quit, logged out, like killed the container, none of that's going to save, unless of course you specify the storage and the volume. And then to kill it, you just simply do what the heck is going? So you simply do a Control-C. I see what I was doing there. And then boom, there we go. Kill the container, spun up a data science environment, tore it down, albeit a basic data science environment. You can get extremely advanced with this, and it could be very cool. I don't know that much yet, but we'll get there. So heading back over to our presentation. So what I wanted to do actually kind of worked. Thankfully, you've been able to see firsthand how all this kind of works. So I'm almost done, I swear. What I'm gonna leave you with is how about we get started? How do we get started into this world of containers? Well, first, you're going to want to work with this on your own time. Incorporate it in your own projects to where you start feeling comfortable, or delegate people on your teams to try it out in a project if you're in a data analytics team. And of course, allocate some training monies for your team to learn this stuff. I promise the ROI will be huge, and going to the powers that be, the decision makers, being a product champion for this, I think would be excellent. And there are also plenty of free resources for you to take advantage of that I'm about to share. But please consult your decision makers about this, and most importantly, consult the operations team. Please, for the love of God, consult IT about this, specifically the operations team if you have one. Your business might actually be leveraging containers already. If they are not yet, I'm sure they're planning to eventually, and it's got to be on their radar at the very least. This technology benefits the whole organization and not just you. The investment of time and resources into adopting this container-based methodology is well worth it once completed. You don't have to go whole hog either. You can supplement containers into teams slowly, doing it project by project or just small. That's the beauty of containers. They can scale up infinitely and scale down. And that's where I'm calling it a wrap. Next, I have some resources for you to share with you. In touching on this, look, I know y'all have 1,000,001 things to learn and to stay current on as data analytics professionals or just being into IT in general. But here's another thing you need to learn. I'll just add it to this to your pile. But seriously, there are some great resources out there to learn this stuff. There are plenty that are free as well, and tons of articles and blogs and tutorials that'll take you from knowing nothing to quite a bit very soon. And I don't want to leave out that the official Docker documentation is phenomenal. It's probably the best technical documentation I've ever had to use. Kubernetes is not as good. It is Docker docs, amazing. So my number one resource and recommendation for y'all is Linux Academy. If you want a training resource, if your company's cool with springing for another training resource, I wholeheartedly recommend Linux Academy for any of this kind of this cloud native type, because these are a bunch of tutorials essentially in classes. What we have right here in the top right corner, these courses we absolutely require anyone that works on our team to take. Like, this is a bare minimum. This Beginner's Guide to Containers and Orchestration was a great course. I was so impressed with it when I took it. And all these are fantastic. I recommend Docker Quick Start for sure. And serverless whenever you need. I believe these 4 at the top, all free. They're all free, which is great. And you know, these are much longer. That's a lot more time investment. Let's not worry about that just yet. But they're there just for you if you want. Docker Mastery, the guy this is a Udemy course, which say what you want about Udemy, but the guy that does this, he literally, today was DockerCon. It was virtual this year, and it was all day. I was half working on this presentation and half just watching Docker videos because I'm a huge freaking nerd. And so Docker Mastery, it's that was a great class. That was my intro to containers originally when I was learning about it when I was like coding a lot, and it's like, oh, I want to use Docker. His course on Kubernetes is really good for when that time comes. This is Martin Fowler's blog or his website. Learning anything from Martin Fowler. He's got amazing content, and he's got a great write-up on microservices. So understanding that, I wholeheartedly recommend you check that out. And then containers on Windows documentation, the Microsoft docs for Docker is great. And I was actually at the SQL Saturday BI edition earlier this year before, you know, our new normal. And Jamie Johnston, Jamie Johnston, he gave a presentation at like the end of the day. It was an awesome presentation where he literally covered everything: Python, data modeling, analytics, Docker, and Kubernetes. I would encourage you to check that out. It was pretty cool, and he created a Kubernetes-based, container-based, and data science environment where he did this really good model on predicting wines, or he did something with wine, and it was really impressive. That ran on AKS, or Azure Kubernetes Service. So those are kind of my rough resources for y'all. Definitely recommend checking that out. And I plan on refining this talk and trying to improve it as best I can. I would like to create a 2.0 version of this talk, and you know, clearly not ramble as much, and make it a little bit more technical. Do some more advanced analytics, container analytics, containerized analytics projects. But what's exciting is that this ecosystem, it's constantly growing and improving every single year. For example, soon Docker will have built-in security features for image scanning. Once this happens, I plan on creating another talk on container security. So that's random, but like why that's a big deal is like that's just a proof of how they're always improving. And then with Docker Compose, they announced some stuff today with Compose, which Compose is going to be very cool for managing your multiple containers. So Balaji, that example with the .NET application and the database, you would want to use Docker Compose for that. You would specify both of those applications and all the commands that are pertinent for that app, for both the app and the database. You'd specify that in that YAML, and then all you would have to do is Docker Compose up, and it makes them live. It spins them up for you, which is pretty cool. And then the image scanning is huge because that's mainly what our product does during my 9 to 5. Getting insights into all the vulnerabilities that are inside your containers and all the layers of that image, that's extremely important for your security and your organization's security. So the fact that Docker is adding that natively, it's awesome. Excuse me, but that's all I got, folks. I am happy to take any questions from here, and thank you so much for your time and your attention. That's all I got.
Excellent. Thanks, Ryan.
Hey, I busted by 30 minutes, but we're still under an hour, 30 minutes at least.
I know, man. So it's a different equation when it's a virtual meeting. But I do have one from Atit. He's asking if you would be sharing the slides. Would you be doing
yeah, I could do that.
Yeah, do you mind throwing it on the Brain group, or if you share it with me, I can send an email to everyone who's registered today.
That'd be awesome. Yeah, absolutely. I'll do that. I'll make a note.
Right. Yeah, man. So I don't think there's any questions for you, but
okay.
That was really interesting. I would love to see a little more like building a project and then deploying it and looking at some scenarios. But what you showed, I think, just hits the spot. Like it really shows.
Absolutely.
It wraps it up.
I was catering to. I was trying to. I kind of had the assumption that maybe a lot of people didn't know have experience with containers or really have much container knowledge. So I kind of curtailed the presentation to just like the general what is the container, and getting started with Docker and everything. And that's why I would like to improve on this and go into more, have like recorded videos that I can give people or like put out there, going through actual tutorials and like data analytics projects. Does that sound good?
Yeah, absolutely. That could
Cool.
be your, when you can come back for another talk.
Yeah, yeah. I'm actually preparing on two different certifications I'm trying to get this summer. So maybe at the end of the summer, potentially, or whenever you'll have me, I guess I could do another presentation or just put out videos.
Excellent.
Yeah. Do I have any? So that was good feedback. I appreciate that. I'll try to make it more technical next time.
Again, I think everything was perfect. You laid out, for somebody who's not experienced with containers, who have not seen them before, I think this works out well. But what I'm saying is this could be like a start from start to stretch all the way, what is containers definition. It's the whole package, right? But you could have a separate presentation, which is a little more technical for techies.
Thank you. Yeah. Right. I could definitely make it more technical. What's that, Lee?
So this is Lee. I would say, first of all, great job. Awesome. I really,
Thank you,
really
sir.
liked it. But I would suggest is starting out with a real simple use case and showing how, what the benefit is, and then expounding on that. I think that might make it a little bit more relevant for people who don't normally use containers.
Got you. Yeah, that's a good point. Thank you.
Yeah. Unfortunately, I have to go. There's some things I have to take out tonight for work. So, but thank you, and thank you, Balaji, for setting it up. And I will talk to you all soon.
All right, Lee.
No problem. Yeah, you have a good night.
Thanks very much. Yeah, you too. Bye.
Yeah.
Okay, so we can just wrap it up in just a minute. So I think we have the recording on, so I'll just post this
Oh,
for all the other brain members